Next is the calomel electrode. Calomel is chemically, calomel means Hg2Cl2, it is mercurous chloride. Like AgCl minus, this is liquid mercury, Hg2Cl2 solid and Cl minus aqueous, or simply even directly you can take that in a test tube, in a glass tube, it is the liquid mercury first that is taken, it is filled with liquid mercury, it is a liquid mercury, but of course here to have a conductor we use a platinum wire, and into this passed is NaCl solution. So, if an NaCl solution is passed, so here you will get a precipitate of Hg2Cl2, this is Hg2Cl2 precipitate you will have, and of course, or it can be kept in a NaCl, a tank of NaCl solution, or else of course, this is as it is what actually we use it. So, this is NaCl solution. So, the reaction is as we have written in the case of AgCl, it is Hg liquid plus Cl minus to give Hg2Cl2 plus 2 electrons. This is solid, this is oxidation, and when it is used as a reduction, Hg2Cl2 plus 2 electrons, this cell reaction will get reversed to give Hg plus 2Cl minus. So, here once again the concentration of the chloride ion is something very important, on whose the EMF of the galvanic cell is entirely dependent on, and overall EMF depends also on the solubility product of the sparingly soluble salt. In the case of AgCl, Ksp is 10 power minus 10 of the order, and of course, here it is Hg2Cl2, whatever may be the Ksp value. The Ksp value, this of course after Nernst equation we see the significance of the Ksp, because in the Nernst equation we are going to discuss how to measure the EMF of a galvanic cell. Now, the solubility product of the salt Hg2Cl2 or AgCl are very important here, based on that the EMF of the cell is going to dependent on. Okay. So, next we will see the Nernst equation.